Today's notes are solving quadratics by square roots. And today we are beginning the fourth quarter. This is our first set of notes, and it is page 44 for the binder. This set of notes continues our unit on quadratics, giving us one more way to solve those polynomials with a degree of 2. So we're going to start here by defining the parts of a radical. And you can see I've already labeled those for you. So we have the nth root of a number a can be written as the radical expression. You can see that the way that that's written symbolically. And we define that bar that goes over our number as the radical. The number underneath that symbol is called the radicand. And then the number that's in the checkmark part of the radical symbol is called the index. Now, when there's no index, it is assumed that n equals 2. And the radical actually is then sometimes called the square root. But in general, we call it the radical symbol for other values of n in that index. If a radical has more than one root, the radical sign indicates only the principal or positive root. So let's take a look at some perfect squares. These will be a very valuable piece, kind of just like our factor chart. In fact, these are on your factor chart, your factor sheet. If you take a look, I've gone through and put these rectangles around all of our perfect squares. And you can see each one of these has a number times itself within the list of factors, and that's what makes it a perfect square. So great spot, additional spot to reference in addition to this set of notes for those values. And those are really going to come in handy when we start simplifying square roots here in this section. So we've simplified a few here, square roots that are perfect squares. So the value underneath the radical, or the radicand, is a perfect square. 16 is a perfect square. It equals 4. Square root of 16 is 4. 121, the square root of 121 is 11. And when we have it written in this way, the 2 in front means multiply, so 2 times 11 is 22. Similarly, square root of 289, 289 is a perfect square. If you type that in your calculator or Desmos, you get 17. And 6 times 17 is 102. And 400, the square root of 400 is 20. And we just multiply again by that. We can call that the coefficient, the number in front of the radical. Here is a process for simplifying non-perfect square roots. Step 1 is to find the largest perfect square that the radicand is divisible by and break down the radical using this number. Secondly, we'll take the square root of the perfect square and take it out of the radical. And third, we'll leave the leftover under the radical symbol. Let's look at example number 5. So we'll start here with writing this as the square root of 16. And then we'll write the square root of what's left there, which is 2. So 32 can be factored into 16 times 2. So we want to be strategic. 16 is the perfect square factor, which can then be simplified to 4. The square root of 16 is 4. And we leave the radical 2 as that square root. Those would be our leftovers. So you may be wondering, how do you know that 16 is the perfect square that goes into 32? And some of that can be a little bit of guess and check. As you think about the number 32, it's even, so we could divide it by 2. And we know, so then you get 16. You can check then your factor sheet and you see 16 is a perfect square. Or again, you could just check our reference and see that 4 squared is equal to 16. And that's what leads you to break it up in that way. Next, we're taking a look at number 6. And we can write that as square root of 36 times the square root of 5. So 36 is the largest perfect square factor of 180. And 36 then simplifies to, the square root of 36 is 6. You can write that as 6 radical 5. Now you may be saying, well, 180, you see that number, and the first factor that comes to your mind that's a perfect square is 9. 9 does go into 180, so we could write that as the square root of 9 times the square root of 20. And we could then simplify the square root of 9 to 3, and we still have the square root of 20. Now the thing here is it's kind of like a fraction that's not fully simplified. You've simplified it, but you haven't fully simplified it. It can be simplified further. Now the square root of 20 still has a perfect square factor, and that is 4. So we can break 20 into, now 3 stays out front, radical 4 is radical 5. And then square root of 4 is 2. Leave that radical 5 underneath. No more perfect square factors left in there. And then 3 times 2 is 6. 6 radical 5 is the answer. Either way, you get to the same place. So if you don't choose the greatest perfect square factor, you'll still get there. You just want to keep asking yourself, are there any perfect square factors of that number left? Number 7, we're going to rewrite the square root of 147 as the square root of 49 times the square root of 3. Another way to check for perfect square factors, you can actually look at that number and divide it by those perfect squares all the way up to halfway to that number. So any perfect square under, so 147 is almost 150, so that would be half of that is 75. So any perfect square at or below 75. So I could start by trying 64 and seeing, does 64 go into 147? Nope. And then does 49 go into 147? Yep. And we would be able to stop there. Square root of 49 is 7, and the radical 3 remains underneath. I'll let you try 8, 9, and 10 on your own, and then you can check those completed notes to make sure you're doing things correctly. Now we're going to move on to what I talked about in the beginning. The goal of this lesson is to solve the quadratics by factoring. So quadratic equations of the form ax squared plus, almost wrote the b in there, that's the whole point, plus c equals 0. So notice there is no middle term, aka the bx part of that quadratic is missing, right? So normally we would see ax squared plus bx plus c equals 0. And this piece right here is missing, and therefore we can solve using this method. This is the only format that works when we're in order to utilize this method. So if x squared equals n, taking the square root of both sides, we get x equals plus or minus radical n. My minus kind of blends in there. Plus or minus the square root of n. Now here's the steps we're going to go through. I will color code those. So we have number 1 is isolate the x squared term. So unlike our previous problems where we were solving to get our quadratic equal to 0, we're going to try and get the x squared all by itself on one side. And the second step is to take the square root of both sides. And the third step is to simplify the radical, like we did on the front. And then don't forget, you'll place that plus or minus to indicate both answers. So isolate the x squared. We'll do a few of these together. Isolate the x squared, we add the 64 to both sides. Feels a little bit like algebra 1. And then step 2, take the square root of both sides. So that's going to be written as the square root of x squared equals the square root of 64. And then our final answer looks like x equals plus or minus 8. So in set notation would be x equals plus or minus 8. Like, take a look at another one. Number 2. We'll start by isolating that x squared piece. Subtract the 8 from both sides. We get 7x squared equals negative 8. And then we would divide both sides by 7. Now we have x squared all by itself. I said, I apologize. 15 minus 8 is 7. And then we divide both sides by 7, giving us 1. X squared equals 1. Our next step is to take the square root of both sides. So the square root of x squared equals the square root of 1. And finally, the square root of 1 is plus or minus positive 1. The reason for that plus or minus is because I can plug in a positive 1 and square it and get 1, or I can plug in a negative 1 and square it and also get 1. So that's why we have those two answers. Number 3. Start by subtracting the 5 from both sides, and we get 81x squared equals 16. Divide both sides by 81. So x squared equals 16 over 81. Next, we'll take the square root of both sides. So the square root of x squared equals the square root of 16 over 81. And you can square root the numerator, square root the denominator, and we get x equals plus or minus 4 over 9. In set notation, x equals plus or minus 4/9. Again, you can use that factor sheet to double check, find the number 16, and you see, eventually you start to realize, okay, 16 is a perfect square, but at first, feel free, use this factor sheet as a great tool. And then also 81, when we find 81 on here, it has a pink rectangle around it, so we know it's a perfect square, but we also see there the 9 times 9 to prove it's a perfect square. Next, we'll do number 5 together. We'll add 9 to both sides. We get 2x squared equals 64. Then we'll divide both sides by 2. So then we get x squared equals 32. Next, we'll take the square root of both sides. And we get x equals plus or minus radical 32. And now for the part that we haven't really had to do too much, step 3, which is to simplify the radical. When I look at 32, I know that it has a perfect square factor of 16. So we have that radical 16 times the radical 2. Square root of 16 is 4. We have 4 radical 2. We're in set notation. Plus or minus 4 radical 2 in our fancy curly braces. Number 8. This time we're subtracting 10 from both sides. So you get 5x squared equals 300. Divide both sides by 5. We get x squared equals 60. Take the square root of both sides. And we get our x equals plus or minus the square root of 60, which looking at 60, maybe you recognize that 4 goes into 60, and that is a perfect square. So again, if you don't see that right away, you can do the guess and check method. Like I said, you could go halfway to the number. It's kind of like a trick. Go halfway to 60. Make my little thought bubble here. You'll have to do number 9, so don't write over it too much. But so halfway to 60 is 30. So then I can start trying perfect squares up to 60. So that goes down to 49, 36, 25, 16, and 4. So try dividing 60 by, I'm sorry, I said way too many. By perfect squares up to 30. So that would be, I just need to try 25, 16, 9, and 4. So you're dividing 25, 16, 9, and 4. And you'll see that the only one that works, the biggest one that works, is 4. And so 4 works. And that's how we know to break this into those two pieces, radical 4, radical 15. So 60 is the number that is associated with the radicand. And then we simplify square root of 4, which is 2, radical 15. Set notation would be curly braces, plus or minus. Don't forget the plus or minus. That's a common mistake. Now that concludes our notes for today. Please feel free to ask questions, come by for help. I'd love to help you. And take your time to do these other questions. Quarter 4 has begun, and taking the time to do all of the examples really does help cement that learning in your brain. And the completed notes, like I said, are in the completed notes folder in Schoology.